Download this code from codegive.com, link in the description below. Certainly. Let's dive into chapter 1 of a tutorial on neural networks in deep learning. This chapter will introduce you to the fundamental concepts of neural networks, how they work, and provide a basic example using Python with tensorflow/keras. Chapter 1, Introduction to Neural Networks. What is a neural network? A neural network is a computational model inspired by the way biological neural networks in the human brain process information. Neural networks consist of interconnected groups of nodes, akin to neurons, which process inputs to produce outputs. Structure of a neural network. 1. Neurons, the basic units of a neural network that receive input, process it, and produce output. 2. Layers. Input layer, the first layer where the model receives input data. Hidden layers, intermediate layers that transform the input into something the output layer can use. There can be one or more hidden layers. Output layer, the final layer that produces the output of the model. 3. Weights and biases, each connection between neurons has an associated weight, and each neuron has a bias. These parameters are adjusted during training to minimize the error in predictions. 4. Activation function, a function applied to the output of each neuron, introducing nonlinearity to the model. Common activation functions include ReLU, sigmoid, and ten. How neural networks work. 1. Forward pass, the input data is passed through the network layer by layer, applying weights, biases, and activation functions at each neuron to produce the output. 2. Loss function, a function that measures the difference between the predicted output and the actual output, ground truth. Common loss functions include mean squared error and cross-entropy loss. 3. Backpropagation, an algorithm used to train the network. It calculates the gradient of the loss function with respect to each weight by applying the chain rule, allowing the weights to be updated to minimize the loss. 4. Optimization, an algorithm, example stochastic gradient descent, ADAM, that adjusts the weights based on the gradients calculated during backpropagation. Code example, building a simple neural network. In this example, we'll create a simple neural network to classify the famousness dataset of handwritten digits using TensorFlow and keras. Requirements. Python. TensorFlow. You can install TensorFlow if you haven't already. Code. Explanation of the code. 1. Data loading, the NIST dataset is loaded and split into training and testing sets. 2. Pre-processing, the images are reshaped and normalized to a range of 0, 1. Labels are converted to one-hot encoding. 3. Model building, a simple convolutional neural network, CNN, architecture is created using keras. 2. Convolutional layers followed by max pooling layers. A flattening layer to convert 2D arrays into 1D. 2. Dense layers, the last one with a softmax activation for classification. 4. Model compilation, the model is compiled with ADAM optimizer and categorical cross-entropy loss. 5. Model training, the model is trained for 5 epochs with a validation split. 6. Model evaluation, the model's accuracy is evaluated on the test set. 7. Plotting results, training and validation accuracy over epochs are plotted. Conclusion. In this chapter, we've introduced the basic concepts of neural networks and built a simple model to classify handwritten digits. In the subsequent chapters, we will explore more advanced topics such as different network architectures, regularization techniques, and practical applications of deep learning. Feel free to ask if you have any questions or need further clarification on any topic. Chapter 1, What is a neural network? Introduction to neural networks. Neural networks are a subset of machine learning algorithms inspired by the structure and function of the human brain. They are designed to recognize patterns, learn from data, and make predictions or decisions based on that data. Neural networks form the backbone of deep learning, which is a more advanced subset of machine learning that uses architectures with many layers of neurons, known as deep neural networks. Key concepts. 1. Neurons, the basic computational units of a neural network. Each neuron takes input, applies a transformation, often a weighted sum followed by a nonlinear activation function, and produces an output. 2. Layers, neurons are organized into layers. Input layer, the first layer that receives the input data. Hidden layers, intermediate layers where computation occurs. There can be multiple hidden layers in deep learning. Output layer, the final layer that produces the prediction or decision based on the input data. 3. Weights and biases. Neural networks learn by adjusting weights and biases through a process called training, which involves minimizing the difference between the predicted output and the actual output, the loss. 4. Activation function, a mathematical function applied to the output of a neuron, introducing nonlinearity to the model. Common activation functions include sigmoid, 10. ReLU, rectified linear unit. 5. Forward propagation, the process of passing inputs through the network to obtain an output. 6. Back propagation, the process of updating weights and biases based on the error of the output. It helps the network learn from the mistakes it makes. Basic structure of a neural network. Here's a simple illustration of a neural network. Code example, a simple neural network. In this section, we will build a simple neural network using Python and the popular deep learning library TensorFlow. Our goal will be to create a neural network to classify handwritten digits using the NIST dataset. Step 1. Install required libraries. You need to have TensorFlow installed. You can install it using pip. Step 2. Import libraries. Step 3. Load the NIST dataset. The NIST dataset consists of 70,000 images of handwritten digits, 0 to 9. It is commonly used for training various image processing systems. Step 4. Build the neural network model. We will create a simple feed-forward neural network with one hidden layer. Step 5. Compile the model. Before training the model, we need to compile it by specifying the loss function, optimizer, and metrics. Step 6. Train the model. Now we can train the model on the training data. Step 7. Evaluate the model. After training, we can evaluate the model on the test data. Conclusion. In this chapter, we covered the basics of neural networks, including their structure and functionality. We also built a simple neural network using TensorFlow to classify handwritten digits from the NIST dataset. This foundational knowledge will serve as a building block for more advanced topics in deep learning in subsequent chapters. Additional resources. TensorFlow documentation, https://www.tensorflow.org. Keras documentation, https://keras.io. Deep Learning Book by Ian Goodfellow, https://www.deeplearningbook.org. With this knowledge, you're now equipped to dive deeper into the world of neural networks and deep learning.